Hi, I'm Patrick O'Byrne, an Excel VBA developer with a special interest in mitigating spreadsheet risk. My topic is how to avoid data loss and corruption when importing text files into Excel. It's for the developer who needs to automate ways of importing text files from anywhere in the world with Unicode file names and content in any character set and encoding. Here is the demo workbook I shall be working with and will make available after the event with all the code you need. My topics will be the Windows file system object, reading the file content as text in Unicode character sets, querying structured data like CSV in 4 ways: file open and VBA open, query tables, ADO record set, and Power Query. So let's start off with that. The first thing you need to know is that if you're using legacy VBA functions like dir and file names and so on, they will not work with Unicode file names, which much of the world outside Western Europe uses. Eastern Europe, the Far East, and so on. And I'm providing you with code to replace these functions with those using a Windows API or the file system object. So I'll give you a demonstration of that. I'm collecting a file name from the sheet, and it is this Greek file name here. It's in a Greek name folder and has a Greek file name. And if you look at this in the VBA IDE, you can see that it can't really display the Greek name. If I debug it, the same thing happens. If I use the message box function, again, it can't display the Greek characters either. So for any work with Unicode file names, I use the Windows API message box W, and I wrap that in a function message box, which converts the familiar string parameters that we use to the pointers that the message box needs. And now you can see there's the file name correctly rendered. Let's have a look at the file properties of this using the classic VB6 legacy methods. There's the dir, the file length, and the file date and time. I get an error at once saying bad file name or number. It can't do it. If I use the file system object, which is the correct way of doing it in Windows now, we get it by, first of all, creating an object with the scripting files system object and calling the getFile method on that with the file path being passed through. And when we do that, we can now display the full path file and name, the size, the date last modified, attributes that are converted from a number into a familiar character code, and the type, in this case, a comma-separated values file. The last thing we'll do is I'll show you how the legacy file open functions, open as, again, don't work with these files. So the rest of the talk will be how to work with these kinds of files. We call a function message fopenbytes, open path name for binary access read, and error message, bad file name or number again. So that's the problem with the legacy file functions. And I've also shown you how to use the file system object to get around that. Now, to read the content of the file, if we can't use open as, I'm going to demonstrate the ADO stream object. All these articles are based upon my various blog articles. I've combined them into one workbook here, so you don't have to go chasing down each individual one. You can if you want to, of course. And essentially, all I need to explain at this stage is that the different kinds of encoding and character sets. We all know that the Windows uses a Western, well, in our case, it uses a Western character set, Windows 1252, which has most of the accented characters for Western European languages, not for Eastern Europe and not for much of the rest of the world, which has graphical character sets. In the text files themselves, the way the data is encoded depends upon where it comes from. Windows 1252 very often ends up in what's called UTF-8 files. You can have plain ANSI files, which still exist, and many downloads are in that format. But UTF-8 is an encoding that has a variable number of bytes per character. A character which only needs 1 byte, like the 256 standard ones, just gets 1 byte. If it's in an expanded character set, then it gets 2 bytes, which means you cannot rely upon looking at 1 byte in isolation and see what character is that. You have to look at the ones before or after it. Fortunately, Windows or Excel handles all that for us. All we have to know is to tell Excel what kind of file that is. There's one more encoding, UTF-16, which is 2 bytes for every character, mainly used for the Far Eastern languages. If you want to know more about this, there's an article by Joel on software. The absolute minimum every software developer must know about Unicode, no excuses, and you can follow up that if you want to know more. It's back from 2003, so this stuff is not new. The way we know what kind of file we have is we look for the byte order marker. It's a header of 2 or 3 bytes, which tell us what kind of data, what kind of encoding is in this file. If it has these 3 bytes here, EF, BB, BF in hex, then it's a UTF-8 file. If it has this pair or this pair, then it's UTF-16. For our purposes, I'm really only going to work on UTF-8. You can see here various folder and file names in different languages of the world, and none of those fit in the standard Windows character set. You have to use Unicode for them. So, how do we read this kind of data from the file? The one I'm going to use is the ADO stream object. In this workbook, I'm giving you in the worksheet the skeleton code, just the minimum that you need to do something. The actual code behind the scenes does a lot more, including all the error checking, of course. Here, we create an object, ADODB stream. We specify type text. We say what character set it is. You have to know what it is. And later on, I'll be showing you how we can infer that. We open it, we load it from the file, and then we read the text from the file into a text string variable. Close it, and we're done. So let's give an example of that. I'm going to go into my test sub. I'll use the getOpen file name to pick a file, and I'm going to pick, let's pick this Greek one here. There are other ones I have. And it calls a function ADO stream file, which actually does the read, where the first thing that it does is it reads 3 bytes from the file only, and it calls the function charset from bytes, which looks at these 3 bytes and says, well, what kind of encoding is this file? In this case, it has found the UTF-8 bytes, so it says, okay, it's a UTF-8. If you didn't have that, you would get nothing out, and you have to maybe guess UTF-8. However, we have it, so we can use it. We call the function read ADO stream text, which creates a new ADODB stream object, sets the type to text. We know the character set, so it sets it. We load from the file, and we read it in 256K chunks at a time. By experimentation, that seems to be the fastest way of reading the file. If you try to read the whole thing at once, it can bog down. So we read the file, return it in the text string variable, and then when we can debug the length of the text, there it is, 221,000 characters. It's a UTF-8 character set, and we'll have a message box showing us the first 1,500 characters of the file. And there it is. It's a file from opengov.gr. By the way, Malwarebytes will warn you about that website, but this is where I got it from, which has the 5 field headers up at the top, and then a series of comments on various articles of interest. And there's a code, a date and time, and so on, conveniently in ISO format, and then a long text comment. Some of these text comments are in quotes because they contain embedded newlines. And these are some of the complications you have to handle. They can also contain quotes inside the quotes, so they're doubled. And there are other complications which we will come across. So that is the demonstration of the reading just the text content of a file. My next topic is going to be on structured files, reading data into tables. Now, to show various ways of importing structured data into Excel, I'll use a couple of different examples first and then settle upon the Greek demo file. Have a look at the screen here. We're going to begin with the simplest method, double-clicking the file, or open in Excel, or workbook open in VBA, and see how they differ. I'll begin with the gene data file. It was a big fuss when they actually had to change the name of genomes in order to ensure that the gene names would not be mangled when imported into Excel. People could have learned how to import them properly, but they figured it was safer to change the name of the genes to suit Excel. Let's have a look at how this works. We look at the folder first. Here we are. And there's the gene data.tab file. Double click that. And it opens in Excel. It's a tab delimited file, so that all looks perfectly well. And indeed, when people look at it first, they thought that's fine. However, if you filter the data, you see among the expected gene names, you see some unexpected numbers appearing. If you pick some of these, we find that, for example, we have March, the 1st of March 2003, the 1st of September 2003. Where do they come from? Well, let's have a look at the file in Notepad in the original form. Here it is. You can see there's the gene name March 3. Excel interpreted that as a date. And the same for September 3. There. So that was March 2003. So double clicking, which is the default way people tend to open files, wasn't very helpful in this case. Let's close off this file and do it the other way. File open in Excel. File open. Show me all the tab files, only one of them. And now we get the file text import wizard, which is much more helpful. We can say, yes, it has headers. It's delimited. It knows it's delimited by a tab. And we can proceed to the next character and say, well, now we know in advance, we can set this column to be text. And now when we finish, it imports the data. Look at the gene symbols, filter. What do you have? Only alphabetic data. So none of this conversion to dates. So that's nice and simple. So if people want to learn how to use a text import wizard, they can avoid that problem. Let's close that and show the third way of doing a straight open in Excel. Open as workbook. Here it is here. I step through here. I get the file name. It's down here. I'll just do a workbooks open. And this looks okay. Once again, filter. Now do you remember that we were seeing 1st of March 2003? Now we have no 2003 dates, but we do have 2021. Let's have a look at that. And what happened is that what was interpreted as the 1st of March 2003 is now being read as the 3rd of March 2021, which is surprising, but these are the kind of differences that you get between the various ways of importing. So definitely text file import wizard is the way to go. So how do you do that in Excel? Before I do that, I'll show you one other one where the file content isn't that nice simple ANSI text that you saw in the G names, but is multilingual. It's a slightly artificial case, but like all good test data, it has a mix of everything. There are 3 columns in the file. The first column has a line feed in the middle of its header. You mix your Chinese and Hungarian and other names in there, various forms of data, including the famous March ones, and another new line just for interest at the end. So let's have a look to see how this file is imported in Excel. If we go to our directory and just double click on the CSV file, it opens it in Excel, right? Auto fit things here. But the data up here isn't anything like what it really is in the file. That effect, where you get this scrambled stuff, is called Moji Bake. If you care to read the articles in Wikipedia or Joel Spolsky on that, you'll find out this is how Unicode data gets misinterpreted in Windows 1252. And as you can see, we get all the dates come out as March 2003. It is, however, it wasn't bothered with the line feed in there. And this, if you look at this a little bit more, you can see there's a line break in the data itself. So that bit was okay, but the character set is completely wrong. So what do? We want to double click, we'll try file open. And it's a text file. No, it's not, it's a CSV file. Yep. And same thing. So that isn't much of a help either. So let's try the workbooks open method. Okay, run this. And unfortunately, no great difference here either, except the dates are now different. They aren't 2003 anymore, they're now back to 2021. So we need to have safer ways of doing this. And just to complete the set, I'll do it with our Greek file name. See how these look. I'll go into the folder, double click the file to open it. And we now have the data in there. When you move across, you can see here is the full length of the file. And you have even these long letters contained in there. So that bit's okay. If you do a file open, there's the CSV file again. Once again, we can now specify things. So we say it's delimited. It's limited by a comma in this case. And everything is general. I could make it all text if you wish, but in this case, general happens to work. And this now comes out with the information you want, except that you will notice by doing file open, the records which had multiple lines in them have now come out as multiple records. So that's how your data gets scrambled. You haven't got the nice one row per record anymore. So That's not a useful way of handling that. So we have to be able to handle all these different combinations. We'll try the test open as workbook just for interest's sake. And okay, that bit's okay. We get the data more or less as before. One row per record. That looks okay. So now you've seen that these methods can misinterpret strings which resemble dates, and only handles the comma and tab delimiters. It won't, for example, handle, it has to use file open where you can specify the semicolon. It won't handle other kinds of delimiters. So how do we do that? Let's have a look at an exercise involving 3 ways of inputting, of opening a text file programmatically in Excel: query tables, IDEO record set, and Power Query. Let's have a look at how this Get Data Wizard is accessed from VBA. It's a query table. That's the legacy wizard, get data from text. And here is the simplest possible version of it. We set up a collection string, which is the word text followed by the path to the file. We add a query table to a worksheet where we give a destination for the data. We say what the text file platform is. 65001 means UTF-8. We say whether it's a comma delimiter or tab or whatever. We specify the column data types that we want. And finally, we refresh the data and it's in there. Let's do a very quick demonstration of that minimum run. And we'll see how it looks. There's the Greek CSV file. The data arrives up in Excel. And okay, it's here, but you can see that the records are, again, split into multiple rows per record. That's because query table cannot handle embedded line feeds. The only way out of it is to strip them out of the file using low-level file operations before you can then open it safely in a query table. To show you how that is done, we look at a practical example where I'll step through it a bit more slowly. It's here. And we'll just get the file name again. We will default to the delimiter, comma, and code page. We've just created a new workbook with one worksheet ready to receive the data. We pass all this stuff into our query text delimited function, which goes as follows. In order to remove any line feeds, it has to create a temporary file where it copies the data to the file, stripping out line feeds on the way. So here's what it does. It creates a temporary full name, which is in our temp folder. And I have a temp folder here in case we want to see it. We read the bytes, all the bytes of the file into a byte array. I quickly look at that just to show you how it does it. It creates an object ADOB stream. It loads from the file, and the bytes is read number of characters. The type is 1, a binary file. And that's all that did. So we now have a byte array which has all the contents of the file. So the first thing we do is we look at the bytes to see, is this by any chance a file with a byte order marker? So we go into the byte array and we say, yes, it has those 3 bytes, so it's a UTF-8 file. That's good. We then call a function called replace bytes, which I won't go into. You can read through it yourself afterwards, which leaves the tabs alone, but changes all new lines with spaces. All new lines within quotes, I should say, within spaces. Obviously, you don't want the ones at the end of the line to be changed. And it also looks at the first line of the file and sees, well, how many columns do we have? What delimiter is in between these? So it infers the best it can from those. So we find out we have a delimiter byte of 44, which is a comma. It's here. And we know it has 5 columns in the file. And we then write these change bytes back to the temporary file. And it just confirms that, yes, this is what we are going to do. We have 60 rows, and we had almost 1,500 embedded new lines. We have a data table, data sheet already defined. We now create the query table as follows. We add a connection to that file. And now we set all the parameters that you need. Just the column width and the background query and all these things. Now, only DB query will come to later for Power Query. This function can be used for both plain text file query tables and Power Query. Here, it's a text import we're looking at the moment. We say it's a delimiter file, and yes, of all the possible delimiters we have here, it's a comma delimiter is true, but not tab delimiter or anything else. And we now have a column data types which will default to being general, which suits us for the moment. You can specify an array of all twos if you want to be all text. We don't need the query table at the end. We don't need the temporary file name. We can delete that. And now when you look at the output, pardon me, here we are. We now have the file correctly read with 1 row per record and all the data fully present. And if you look at this, you can see all the data is in there. That's fine. That's how that query table works. Now, the other way of doing it is the ADO record set. This is useful because it does handle embedded new lines. So we don't need to worry about all the business about writing out a temporary file and changing all the bytes, all the line feeds within quotes to spaces. However, its own limitation is that it can't open Unicode file names. So we still have to create a temporary file, but just copying the file to a plain ANSI file name and then opening that. And its other bugbear is that if your delimiter is anything other than a comma, like if it's a tab or a semicolon, you have to create a schema.ini file. So life gets complicated, but it's a record set. It's a nice way of getting a memory structure from all this. So let's see how it works. We go in here, we get the file name, we create a new workbook with 1 worksheet to hold the result, and now we go into our load worksheet from delimited text file sub. And the way this works is, yes, it is going to make a safe copy of the file. It splits the original path and name into the various parts. There's the file name only, and there's the folder name coming out of it. And if it's if you're required to copy, which we do, it's going to get a temporary name and copy the file from the original to this temporary name. And we get that, and there it is. It's in the temp folder, and its name is rad et2ec. That's fine. We then read all the bytes from the file into a byte array, and once again infer the character set from the first 3 bytes. And we also work out what the code page corresponding to that is. The code page for UTF-8 here is 65001. We also count the number of columns in the first line. We work out the delimiter character, and we now say, yes, this is now delimited with a comma. And then we have a little, if we had, by the way, anything other than a comma, we would have to create a schema ini file, which fortunately I don't have to show now. You can read that yourself later. We're now ready to look at getting the data. Before we do, there's one more little safety check that we do. We get the count of records in the file. Our SQL query simply says, show us how many records you have in the file. And then we compare that to the number of available rows in the worksheet. If a certain well-known health authority had done that before importing COVID lab test results into Excel, it wouldn't have overflowed the sheet and lost COVID test results. So let's go ahead and, yeah, it's going to select count from that. And it has one field, obviously. And now it passed the test. We have a million rows in the sheet. We now have a message that we can display. Oops. We have that many lines, that many columns. Yes, it's a comma. Ready to proceed? Yes, we are. And this is the guts of it. Get an ADO record set from a text file. We once again select it, break it into its path and name. We put the folder name into the connection string. By the way, this IMX equals 1 is important. If we have mixed data types, we want everything coming in as text. And select is select all from that file name. So we're now ready to open the record set, which is here. Ready to open the record set. It's pretty quick. And we get a message box saying, okay, we found 5 fields of 117 records from the 118 lines. And we then copy that record set to a sheet. That's just a one-line function. And we can run our way out of this. And here, once again, is the data. And as you can see, it now has correctly imported the records, 1 row per record, and all the line feeds properly preserved. So that's a useful way of doing it, provided you're prepared to put up with the schema.ini fussing for tab or semicolon delimited files. Now, for the final method, which can handle everything, and this is where we want to end up, we're going to look at Power Query. And I'm doing it in a slightly more complicated way than I perhaps need to, just to demonstrate the power of Power Query in giving information about the file. So the first thing we need to know that we write functions, we write code in Power Query using the M language. So we create an M formula, which all goes something like, let the source be equal to the file contents of the file, and then you do something with that source table, and you dump it out ultimately. To dump it out, you create a Power Query object in the active workbook queries collection using any query name and the formula that you've created. To actually see that, you add a list table to the sheet where its source is a Power Query. And then with the query table, you put in the command text, select everything from the query name, refresh it, and it ends up on the sheet. So we'll demonstrate that. But in order to demonstrate how it works, I'm going to give you a bit of background into how we get some of the data that we need for Power Query, like the kind of data we have in the file, the encoding, the character set, and the delimiter. And here we're using Power Query itself, rather than doing our own inference by counting bytes or that kind of thing. So the first thing that we do is we use an M formula. Let the source be the contents of the file, and the info is infer the content type from the source. And the content type could be text tab separated values or text CSV, for example. The content encoding 6501 means UTF-8. And the potential delimiters is itself a table. So you have to make a separate query to extract that. So we now know that we can treat this as a UTF-8 file. Then we issue another formula to Power Query saying, okay, now give me from the content type the potential delimiters in this file. So it says, okay, I looked through the whole file and I found that the tab character in this particular file, file.tab, has 14 null-empty columns if we use tab as delimiter, but only 1 if we use other ones. So we're going to use the tab. This, by the way, is a white space value, which I never find useful, so I just ignore it. And the final one, which is purely informational, statistical, let's throw in for fun, is the table profile, which we table.profile from the table, which gives us for each column the min, the max, the number of data values, and the number of distinct data values in that, which is interesting to have. So let's have a look at demonstrating that. We go into the test PQ CSV function, and I'll step through this. Once again, we get the file name, and we create a new worksheet, and we add a couple of other worksheets. One is going to hold the content type data, the other the potential delimiter data. We don't need to keep these at the end. We could delete them, but I'm keeping them for demonstration purposes. The first thing we do is we infer the content type. So I'm going to step into this to show you how it works. We create a formula. Let the source be the file contents of the full name, and we want to infer the content type. And we then add a query, a Power Query, to the worksheet, and we do Power Query to list table. You notice that took a little bit longer than all the other functions we've been working with, but it's pretty quick. Here's how it works. To the worksheet, we add a list object where the source is an OLADB provider. Location is the query name. And with its query table, we now define all these here. We select everything from the query name, do all these things here, refresh the data. Again, you know, it took a second or two, but that's fairly constant almost regardless of the size of the file. And then we don't need the query table anymore. We can delete that. And then we end up with, I add a text box just to show me what's in the sheet. So let's now have a look at sheet 6. Look at the infer content type. That's the text box I added showing the formula that we used. And we know, yes, it's text CSV and it's 6501. So now we know it's a UTF-8 file. Go back to our code. Do we have a content type row in here? Yes, we do. And if it has that, we know it's a VB tab. Otherwise, it's a comma. But there could be other ones. So we do have a double check later on for potential delimiters. We also look for a content encoding. Do we have that? Yes, we do. And the encoding is 6501. That's fine. Now we do the same thing again, but this time we get out the table CSV potential delimiters. And once again, we go to the same query. I'll just skip over the running of the query. And I'll show you the result. Similar to before. Now we have potential delimiter table. And we notice that in this case, the comma delimiter has the most columns. It's 5 columns. So we pick the comma as a delimiter. And it also does a double check. If it finds that the delimiter character finds here isn't the same as the one we found earlier, it'll say, well, which do you want? And that happens with, say, semicolon delimiters and other such things. So we now go ahead, we can now, we've done that. We now know the encoding, we know the delimiter, we can now really get the data. So I'm doing a table profile just for sheer interest. I won't go into it in detail now. You can look at that in your own time. And now we're ready to actually get the data itself. So we do the same thing again. We're now looking at the original M formula. We're going directly to the PQ CSV table, and we have, and the formula is in here, and you'll see it when we bring it out of the sheet. Let's have a look at the sheet. There is the formula that we created. It gets the contents of the file, and we now know it's a CSV. There's the encoding, there's the delimiter. We got that data using Power Query itself. And we say what the various headers are. And we then dump the whole thing to a sheet. And as you can see, we have one row per record. And the data is present as expected. Now, there you are. Makes it a bit easier to read. Now, so that is the successful use of Power Query to query this file, and using Power Query to tell us what kind of data is in there. So it's the most successfully automatable method in VBA. I hope you find that useful. If you have any questions, you can put them to me afterwards or contact me using the contact information you'll find on the workbook. There is the address of the workbook that you can download yourself afterwards. And good luck with your work with text files from any part of the world in any encoding. Thank you.